Welcome everybody to this week's Live from the IT Room podcast with Supreme Systems and our special guest this week, Moonwalk Universal. We have with us Mike Harvey, the founder of Moonwalk Universal. Hello, Mike.
Hi, Julian. How do you do?
I'm very well, thank you. Yourself?
Good.
Today we're going to take a look at the Moonwalk data archiving and data management solution, and Mike is going to run us through the user interface and show us some of the features and benefits of the solution. So to start with, Mike, can you tell us a little bit about why Moonwalk was created and some of the background to the application?
Yeah, absolutely. So Moonwalk was designed to give customers granular control over their unstructured data. And when we say unstructured data, we're talking about files in file systems or objects in object stores, whether it's on-prem or in the cloud. We're not talking about rows inside databases, right? So we're not talking about structured data, we're talking about unstructured data, which is notoriously difficult to manage. And one of the reasons that Moonwalk was designed was to give customers the ability to control where they store their unstructured data and for how long they keep it. Because as you probably know, and as most people listening to this podcast will know, is that most of the files that they have on their file server, whether it's a Windows system, a NetApp system, an Isilon system, whatever it happens to be, most of the files that they have will not have been touched by anyone, by any human user or any application in a very long period of time. In fact, what we find when we do analyses of customer environments is that up to 70% of data can be untouched for 12 months or more. So if we have real facts that tell us most of the data set isn't being used day to day, why do we spend so much backing up, making available, providing high performance storage for, let's say, 70% of the data set that no one's actually using? But it's difficult for customers to, number one, know what the active data set is, or something we call the hot data set, to understand the temperature of data scientifically, and also how then do they take action. Let's say you can identify this inactive or this cool data set. What do you do with it? What do you do about it? So Moonwalk is a combination of capabilities: data connectors for file systems and protocols, data connectors for object stores and cloud endpoints like Amazon S3 and compatibles, Azure, Google, these kinds of cloud services. But it also has a policy engine and a rules engine that allows customers to create business rules, if you like, that tell the system what to do, what to look for, and when those sorts of file candidates or those sorts of profiles or those sorts of patterns are identified, what action to take. So what customers tend to do with our technology is to build their own customized policies, which are very easy to build, to address their own data profile. And one of the top use cases that we see, and certainly the use case that delivers the greatest and the fastest ROI, would be storage optimization, or sometimes it's called storage tiering, or sometimes it's called archive. And this is that method of identifying inactive data or cool data or cold data and moving it from where it is on expensive storage, where it is backed up, where it contributes to cost and time with respect to disaster recovery, which is something we're going to talk a little bit later. And it shifts the content to something that's more appropriate, something that is more affordable or lower cost. And cloud storage is becoming very popular right now to support this use case. But some of the the secret sauce within the Moonwalk technology is that it can shift the content of files without shifting the file itself. Okay. So this sort of means you could take a file and punch a hole in it, remove its content, put that content, let's say in Amazon or Azure or Google or a cloud endpoint of some kind, but leave a shell behind, an empty file, if you like, that has all of the metadata, that has the original size and the original name. And the purpose of that is that a user or application can't tell the difference between one of these empty files and the original file.
So essentially what we're talking about is a system that identifies data by whatever means, which we can talk about in a moment, and then can move that data to another location where it will have no impact on recovery times, lowering your live data backup costs, increasing storage, etc. But yet it does not disrupt the end user in any way. They see the data as though it was still in its original location.
Yeah, exactly. It's almost like if you have a garage at home that's full of boxes and stuff, and you can't park your car in there, right? And most of those things you haven't used. It's like being able to push all of that material out into some offsite storage, but still have a representation of that in your garage. So when you want to go and find the Christmas decorations, you don't have to go to offsite storage. You just go to your garage and there's an empty box that's really flat, and you just touch it and the Christmas decorations magically appear.
That sounds really quite revolutionary, especially as one of the largest issues that most people have with archives is having to manage a completely separate file structure and all of the headaches that go with that. And then people get confused. I'm looking for this file, but I don't know whether to look in this place or that place, and I may have two completely different file levels.
Yeah, correct. I mean, that's certainly a good point. And then when you overlay the cost, the risk, and the complexity of compliance and governance, it doesn't just become difficult to find data and make sense of it. It can become a legal issue, or certainly a very expensive, regulatory fine if someone happens to be in one of those industries and they can't get access or locate archive data that's offsite. This removes those challenges.
Yeah. You mentioned earlier about the identifiers, the ways in which Moonwalk can identify data. Can you tell us a little bit more about the range of those?
Yeah, absolutely. So if you can see the interface that we're looking at here, this is the Moonwalk dashboard in the command center, which is called Admin Center. And we use this concept of a rule. And a rule allows you to create a custom filter, if you like. So let's just call this rule number 1, just as an example. Moonwalk gives you the ability to match file names using patterns. And that could be something like star.pdf or star.doc or docx or star.xls or xls or whatever the new one is, right? So you can search, types of files by their extension. But you can also use patterns, because Moonwalk supports something called regular expressions, which allows you to enter a filter. Let's say you're looking for all the files that start with an alpha character, and there are 2 of those, and then there can be 2 numbers, and then there could be a word, maybe marketing or manufacturing, and then there could be some other things. So regular expressions are quite well understood in the industry as filters or pattern matching. So anything that's in the name of the file, you can build a filter based on a rule. But we also allow you to look at things like the size of the files, so the minimum size and the maximum size. So you could be looking at banding, if you like. We call that size banding. And of course, you have all of the different date or time attributes. And this is usually important when you're trying to find inactive data.
Yeah.
Because something that really stands out is when you look at files with an access time of, let's say, less than 12 months or 2 years, or whatever the case may be. And that just means no application or user has accessed that file in that time. Of course, we give you the ability to also look at the owner of files as well. So you might be, perhaps you have a rule where you're interested in finding all of the inactive data based on, let's say a file that hasn't been accessed in 12 months or more, as an example, but you want to negate that rule by saying if it belongs to anyone in an executive group, or if it belongs to the CEO or something like that, you don't want to do it.
Okay,
so
makes sense.
And what Moonwalk gives you the ability to do is to create, I don't know if you can see this little button up here on the left It's called a compound rule, and I think the icon's supposed to be a mortar and pestle, like a compounding chemist.
That's
right?
what it looks like. Yeah.
Oh, good. And so what that allows you to do is to connect rules together. So we could have our find all of the files that haven't been accessed for 12 months or more rule, and then we could have another rule that simply says CEO, and we can combine those rules together, and we can decide whether we negate them or whether we add them. It can give you it does give you the ability to create quite granular rules that can be complex. But what we find is if you're able to reduce the storage by 70 to 80% with a single rule, then you've really got a lot of bang for buck just in that one step. And it keeps it quite simple. But let's say you were looking to find all of the files that were created by a particular user between this date and this date, right? For maybe compliance, or maybe there's a legal issue, whatever the case may be. So if the file system metadata provides the actionable intelligence for your objective, Moonwalk gives you the ability to create any rule that matches those conditions. But as I said, from a storage optimization point of view, to sweat the assets of expensive storage, to reduce the backup, to save on DR cost and DR time, simply looking for stale data, cold data, or not hot data, the active data set, that's going to give you the biggest bang for the buck, and certainly the largest and the fastest ROI.
Excellent. I like the way that you don't have to create an individual rule for every possible scenario, that you can create more general rules and then combine them in either an additive or a subtractive way. That's a really good way to manage the identifiers, the data identifiers.
It's a good point you make, because when you don't want to bind a piece of logic or a filter to its action. It's when you create rules in Moonwalk, you're really building a library of filters. So then when you, let's say, get into the policy section, you're able to simply select your rules that you've created before. And so that means you're able to reuse those rules, and you might have one administrator or a data custodian or a data steward who has a better understanding of the data, and they can go ahead and create those rules, but other folks can build the policy. So if you see here in the policy interface, we're able to select the rules that we've already created, and they're not bound in a hard or tight way to the policy itself, because I can go into any policy at any time and I can change those rules if it's appropriate, and it's not going to do anything to the data. Moonwalk is designed to be flexible. It's designed so you can start slowly. For example, when most customers deploy Moonwalk, they haven't done a data analysis. They may not have a data steward, so they may not really know their data all that well. But this technology gives them the ability to certainly create the rules as they get a better understanding, but it also gives them the ability to have some data insight. So we have a full reporting engine that will produce data assessments based on, again, the rules that are created. It could be something like all files if you wanted to see everything, or maybe files created by these users, or files created between these times, right? So any actionable intelligence, as we said, that exists in file metadata, you can create not only rules to address that, but you can see full reports based on that information. And Moonwalk will even give you long-term trends based on its analysis of the storage consumption and the data growth over time. So as you can see here, we've got these last 3 bars, which are a projection of what the storage will be or what the consumption will be. And I mean, this is a demo system, so you can obviously see at some point months ago, I added more data to my demo system, so we got this jump. If you were to run this against a real data set, you would see a histogram that looked a bit more normal, right? A bit more organic. But this is the direction you'd expect, right? You'd expect the bars on the left to be lower than the bars on the right, and you'd expect those bars every 12 months or so to be doubling. That's what you'd expect.
So there are analysis tools here that the IT managers and administrators would find extremely useful just in their own right, let alone the primary focus of Moonwalk with the management and archiving functions.
Yeah, I mean, I would say, we built them to be, independent of one another. For example, one of our customers in the United States, Stanford University, they found simply by doing a file type breakdown, they found that they had millions and millions and millions of files for which they no longer owned the applications to read them.
Wow.
And this is quite common when you have older environments where 10 years ago, let's say the customer migrated from one application to another, but nobody cleaned up the data. So they probably copied the data or they transposed the data so it could be read by the new application, but they never cleaned up the old data. I mean, it's a good way to look for junk.
Now we understand a little bit about what Moonwalk does in terms of the data archiving and the data analysis. Let's talk briefly about some of the benefits of that. As you've touched on already, obvious benefits would be reducing the amount of live data that's being kept usually on-premise infrastructure. What are the benefits associated with reducing that data?
Well, let's say that you have infrastructure that has no data management in place, that every file that has ever been created is stored on your on-prem primary storage. And when we say primary storage, for most organizations, that is the only storage that they have. Right?
Yes.
It is their file server or file server cluster. And larger organizations can have hundreds or thousands of these things. But even smaller organizations, they still have to manage the cost and the complexity of file storage, even if there's, say, 2 or 3 Windows file servers, or maybe they're clusters, or maybe there's 10 Windows file servers, right? So the primary storage concept is basically every file is sitting on-prem and is treated exactly the same way as every other file. So if you were to take the yearly cost of the storage environment, hardware, software, data center cost, cooling, power, data comms, staff, everything, right? If you were to take that cost over a 12-month period and divide it by the number of files you had, you'd get an even number, right? Well, it may not be an even number, but you get the same number because every file is being treated the same way. But then if you were to look at the access frequency of those files, you'd probably find that 70 to 80% of those files weren't being accessed at all.
Yeah.
And so all the money that's being spent supporting that data set, it's wasted. Now, just because data is old and no one's using it doesn't mean it has zero value, but it has less value. So Moonwalk gives customers the ability to look at their data through that lens, through a lens of value, and treat things according to the value that the organization prescribes. Let's say you want to use a cloud endpoint, which is a really good idea because the cost per month for Amazon or Azure or Google storage is very, very low, and it's object storage. So you don't have to worry about structures and directory depths and volumes and LUNs and all of those things. They just don't even exist. And the price that you pay for the storage is the total price. There's no additional costs for data center space or heating or cooling or anything, right? So that's the total. That's the own cost. And then being able to shift data out so that you don't have to upgrade your servers or your storage is probably the number one cost saving event. So let's say a customer is approaching an upgrade event. They only have about 5% capacity left on their file server or their cluster. Well, data's coming in every day. They have to do something. And now they're going to have an event, a cost event, where they have to upgrade their system, buy more storage. And there's chances are there's going to be some downtime. Not always, because products are a lot better today, but there might be some downtime when they add more capacity to the system. And then in 6 months, that capacity is going to be consumed again. And that's just what customers have gotten used to over the last 2 decades, right? The CFO is used to purchase requests hitting the desk for storage over and over, probably every 6 months. But with this technology, the customer can identify older data and they can, send that older data to a cloud endpoint. There's no purchase request. They only pay for what they use. And let's be conservative. Let's say it's 50% of the data set that you can migrate or archive outbound. All of a sudden, 50% of the capacity of that on-prem asset has been restored and nobody had to move anything, right?
So essentially, it's extending the life of your existing hardware. I can see that being a massive saving periodically, but the obvious saving to me would be with backup costs, which are generally linked directly to the amount of data that you're backing. So backing up each day. So as an ongoing cost, would it be true that savings on operational costs for backup and disaster recovery would match or even outpace that?
Yeah, and certainly over time, the more you use technology like this, the more you save over time. But if we have a look at one of these reports that I had here, one of the first widgets we show is a donut chart, and we use the term migration status. And what this is telling us is that 76.7% of this data set has been migrated. So almost 80% of the data in this system is actually not in this system. It's sitting in a cloud endpoint. But all of those empty files, all those representational files are still in the system, right? They're still being served to users. And that's a very healthy looking system. This is why it's green. So if you imagine this in a production environment, if we had, say, a petabyte of data, that means 760 odd terabytes is sitting in a cloud where it's being backed up, or there's enough reps or erasure encoding such that doesn't have to be backed up, but it's 11 nines of availability, right? So let's call it 3/4. So on-prem, I have 250 odd terabytes, and that 250 odd terabytes is being backed up by whatever backup strategy we have. Maybe we snapshot on the storage, every 10 minutes, and we keep those for a week, and we snap dailies, and we keep those, for a month, and we snap monthlies, and we keep them for a year, something like that. Yeah. We still have to park those snapshots somewhere. And what you have with this sort of technology is a very elegant way to take the inactive data, or indeed whatever data you want, and move it out of the backup flow. So what it means is that the difference between having 3/4 of our data off-prem in a cloud endpoint and not on-prem means that our backup is only a quarter of the size that it used to be, and it runs 4 times faster. And depending on what backup strategy I've got, I could maybe do a full backup every day instead of incrementals or differentials or these sorts of things, because I only have to concentrate on that, the data that's remained behind, if you will, which is in most cases the active data set. And the same would hold true for disaster recovery, right? So if we had a disaster, I don't have to recover the balance. So my recovery is 4 times faster. And it's only a quarter of the cost. So by whatever factor you're able to, in this case, we call it storage migration, which is why it's called migration status. By whatever factor you're able to offload, that same factor will guide your cost savings. So we should expect 3/4 of the cost of backup and DR to simply be gone. We should expect it to collapse by that amount.
That's quite a stunning reduction on costs and on risk in both instances. Another feature of Moonwalk that I came across in the literature was there's no single point of failure, and talking about the idea of the fact that there's no middleware. And I understand that this is one of the things that differentiates Moonwalk from any competition. Can you tell us a little bit about that?
Yeah, so the way that Moonwalk's been designed, the interface we're looking at here runs in the Moonwalk Admin Center. But the Admin Center doesn't have any storage ownership. It doesn't play a role in storage. It's a data mover, it's an API, it's like a traffic cop, right? When we execute one of those policies that we created, which will execute those rules that we created, Moonwalk directs the storage to take certain actions. But the file servers are responsible for shipping their data across the network to whatever cloud endpoint or whatever storage endpoint you're using. The data flow doesn't come through the Moonwalk Admin Center. What it means is if this system we're looking at, if it were 100% offline, if the server was toast, you could smell that burning electric smell, right? It's completely offline. It won't affect data access.
Right.
So users or applications trying to access those, quote unquote empty files, the data will still be retrieved. The only thing that will happen is that we won't be able to look at this interface We won't be able to create new policies, and we won't be able to run policies. But 100% of the data is still available, assuming that the network is, right? Assuming that this was the only thing that failed. So when we say no introduced points of failure, we can't guarantee that the customer's network or the internet provider will be, running all the time. But when the customer uses Moonwalk, it doesn't introduce a single point of failure to their network. And it's the only technology that works that way. And all of our patents are granted based on that, that novel invention, that this engine is outside the data path. It's a traffic cop. It's not in the middle, serving storage, proxying storage, and doing things like that. It just simply doesn't work that way.
That's amazing. Another feature that I read about of Moonwalk is the fact that it's almost infinitely scalable. Can you explain a bit about what that means, really?
Yeah, sure. And this is, again, virtue of the fact that the technology is out of band. The technical name for that architecturally is something called disintermediation. So there's no intermediary. And because there's no intermediary, Moonwalk doesn't put a scalability limitation on the environment. So unlike other products that are not disintermediated, they will have a database or something like this in the middle somewhere. And so therefore, the scalability of the solution is limited to the number of records that database can support. And so let's say you're in a large deployment where customers might be using NetApps or Isolons. Those things can support billions and billions and billions of files and objects. But if the data management solution, let's say it stops working at 1 billion or 100 million or 500 million, a ceiling has been introduced that has nothing to do with the storage itself, right? Your NetApps and Isolons can keep scaling, but the data management framework cannot.
Right.
And so what those customers have to do, they have to deploy another one, which then starts to get very, very complicated and very expensive. So by virtue of the fact that Moonwalk is disintermediated, that there is no database, that there is no middleware, there's no distributed hash table, there's no index, there's nothing that has to scale. This technology will scale as far as the customer's infrastructure can scale because it simply doesn't get in the way of that.
So what if a new customer comes to Moonwalk, they like the proposition, they're looking to reduce their costs on primary storage and potentially reduce their risk in terms of disaster recovery? What would be the first stages? What would be the first process by which they go through to evaluate Moonwalk?
So there's a couple of approaches. They can engage with a partner, a Moonwalk partner or SI or VAR, or they can go ahead and download our starter edition and run a report like we've seen. And that's going to tell them the extent to which their data is, let's say, old. And they can basically calculate the savings based on their own data, looking at it, from a scientific point of view. Not a finger in the air point of view, but let me know exactly, we call it data demographics. Let me know what my data demographics are, and then I can calculate what my savings will be. And that's the best way to get started, to get some kind of visibility over the data set itself, because every environment's different, right? Every environment's different. And one thing I'll say that just, we've been talking about finding the inactive data, the old data, and shipping that off to, let's say, a cloud endpoint. Something that we're seeing more commonplace these days is customers being more aggressive. So let's say I have the communications infrastructure and the latency such that I can recall a file from a cloud in a couple of seconds, which might be comparable to how that file would be recalled if I had it on-prem.
Yeah.
So I can go ahead and create a rule that is really aggressive towards those files based on their size. So I don't really care how old they are. I just know that if I have a file that's, say, smaller than 10 megabytes, and after it's been 1 day old, I go ahead and send that out. So what we're seeing happening is customers are using latency and recall time more as a selector on what data they ship out than its age.
Okay, so further opportunities to make savings there and with no impact on the end user at all.
Yeah, exactly. And you're seeing a lot of this service level agreement focused thinking. We know that we should optimize everything that we do, but if we focus more on what our internal customers are expecting, then that can be a different way of looking at the same problem, right? Because when we say, let's go ahead and archive old data, we're making an assumption that just because it's old and no one's been using it, that the chance of someone using it tomorrow is low, right? So we're using we're using a logic and we're using intuition to make that decision. But if we use the size of the data, knowing how long it takes to bring data back, we're taking a different view, right? We're not trying to second guess whether someone will use something or not tomorrow. We're saying, well, even if they do, it doesn't matter because we can recall it in a split second. And by the time the application opens, the data will already be back.
We've talked about, again, this links back to the different identifiers for the data and the ways that can be used. That also ties in to the different scenarios that you can create using your rule sets to predict how much data can be, let's say, safely archived or archived without it impacting users in any way whatsoever. So this all ties into another thing that you mentioned, which is the return on investment. I understand that Moonwalk gives you the ability to use these rules and different identifiers to create predictions on what your savings will be over time.
Yeah, exactly. I mean, if you look at the long-term trend projections here, the system is looking at the consumption of the past to give you an idea of what you're going to get in the future. Let's say you create a rule that's looking for files that haven't been accessed in 12 months or more, or 24 months or more, and you create that report. You'll see something like this, which will show you file breakdown, consumption over time. You can even see, file owner breakdown, but it's not very useful in this data set because there's only one user. What's important about that is you can look at these, a customer can look at these totals, and then they can simply calculate the difference between what they spend, or let's say what they spent for the last 12 months versus what it would cost to send to a cloud endpoint. It's different for every site, right? Everyone's data is different, but what's important to remember is that when a customer implements this kind of solution, they will be pushing the next storage upgrade way out into the future. If you could empty your file servers by 75%, let's say today, but you're constantly running data management policies, how long will it take for that to even get back to 80% full? It probably won't, because you're always running policies that are always pushing old data away. So unless the data profile changes, right? That if the data profile changed dramatically, that could change things. But most of the time, a Moonwalk customer will have to replace the storage hardware because of its age, not because it filled up.
Which massively extends the life of most hardware, as the typical reason to upgrade is to increase resource availability in some way, and quite often the top of that list is going to be storage capacity.
Yeah, it's usually the most expensive part of IT spend. And if we go back to that, that analogy I used before, let's say this donut chart was representing a petabyte of real storage, and we were able to identify 3/4 of that. We shipped that out to a cloud. That's great, but we already bought that petabyte of storage, right? It's already sitting in our infrastructure. Now we fill it up, but we're still pushing old data out. When that infrastructure becomes so old that we either have to replace it or, let's say, trickle it down to some other department, we don't have a 1 petabyte storage problem. We only have a 250 terabyte problem, right? Yeah. So when we replace that storage hardware, we actually buy less. And that never happened in the world before. You never bought less in storage, but we can do that now. And when we have customers who have, let's say, been using the product for 3 to 5 years, and they're in that position, more often than not, they'll, let's continue this analogy, they might buy 300 terabytes of storage, but they buy faster storage. Maybe they buy flash. So they're actually in a better situation than they were, and they're spending less money. So they're getting better performance. They have a faster disaster recovery should that ever happen, but they have lower cost. It's really a win-win-win scenario.
Absolutely. The missing piece of the puzzle, the part that we haven't spoken about, is the cloud part itself. And while I understand that that's not essentially a Moonwalk decision, tell us a little bit about your experience of the different options for cloud storage. So, for instance, I know that a recent implementation that we did of Moonwalk chose the Wasabi platform as a very inexpensive place to store what I'll call archive data, although I know that's not strictly the case. What's your own experience of the various platforms?
Look, I think that there's Amazon S3 proper, Azure and Google are all solid choices. It will depend where your data center is located, depend where you are located. What is the latency to the closest cloud endpoint? So that's a factor. But within the Amazon S3 protocol universe, there are other providers like, as you say, Wasabi. And they offer great infrastructure and they have very aggressive pricing, not just in terms of the cost of storage per month, but also ingress and egress charges. And that's often something that customers that can be easy to overlook.
Yeah.
And that's something that you really do want to pay attention to, especially if you have large data sets, because you don't want to be financially penalized for bringing data back, because that's the purpose, right? And you also don't want to be financially penalized for changing from one provider to another. And Moonwalk has an operation type that allows you to, we call it a change tier, but it means that you can change an endpoint. So let's say I use Amazon. Let's go back to my idea. Data that hasn't been accessed in 12 months or more, I move the content to Amazon S3. But then I could have another policy that says, and we're just talking about that data on S3, if no one has used that in a year, then I want to move that to Azure. And then if no one's used that in 3 years, I want to move it to Google. So Moonwalk allows you to connect as many cloud endpoints as you want and to use them as you wish. But that also would mean, let's say a better price could be negotiated with another cloud vendor. With a click of a button, Moonwalk can move all of those objects from one cloud endpoint to another. And this is where the cost of ingress and egress matters, because some cloud providers charge quite a lot for you to bring data out of their infrastructure. So it's just something to keep your eye on. But as I said, there's lots of good options there. Certainly the big three are good. IBM have good cloud offerings. They're certainly a candidate. Wasabi is definitely a candidate. Backblaze is a candidate. You really want to look at where the infrastructure is relative to where you are. Latency is pretty important. And of course, the bigger the name, the more likely it is that the 11 nines they promise are going to be delivered. More likely, but not guaranteed.
But essentially, Moonwalk gives you the flexibility to adapt with those as new and better offerings come along, or more economical offerings come along. It's very easy for you to go with the flow and change with the times.
You're definitely not locked into any endpoint. You can change it whenever you like, or you can blend them together. Right? Let's say you find, let's just use this as an example. Let's say Amazon S3 is great for your first tier because of its proximity to your data center. But for very old data, you're happy to wait a bit longer. And maybe Azure has a better offering for very, very cold data, but it's a little bit further away. You can blend those things together in a policy that will continue to push data further and further away, cheaper and cheaper as it gets older. Because as it gets older, the chance of it being recalled, approaches a probability that is very, very close to zero. But if it does get recalled, that it's going to come back, and a user might just have to wait. They might have to wait 30 seconds.
Well, Mike, I think we covered all of the salient points. Is there anything that you would like to cover that we haven't so far?
Not really. I think the folks listening to this are interested. Get your hands on the software and just run a report on your own data to see what it really looks like and the extent to which it could optimize. There's no risk and there's no harm in having a look. I think that's a good place to start. Or certainly, I get in touch with the folks at Supreme.
Thank you for that. Okay, Mike, well, we'll wrap it up there. Thank you very much for your time today. The product is amazing. That's why we were very quick to get in touch with you guys when we came across it. So congratulations on such a fabulous product. And thank you very much for your time and your help today.
Yeah, my pleasure.